Thank you so much for coming to the session. So today we're going to spend 30 minutes to talk about what's new in Visual Studio Code for C++ development. I don't know why this is going by itself. So my name is Rong Lu, and I am a program manager on the C++ team at Microsoft. And quick agenda here. So how many of you have been using VS Code for C++? Wow, that's a lot. That's, I would say, 60%. That's awesome. And how many of you were at my session last year? None? Oh, one. Oh, thank you. Oh, two. Thank you for coming again. So for those of you who haven't been using VS Code, so I'm going to do a quick introduction to what VS Code is. And then we're going to focus on what's new since last year we talked about this. And we're going to do a lot of demos, and then we'll finish with a summary. So what is VS Code? A lightweight but very powerful code editor. It's free, open source, and runs everywhere. By everywhere, we mean Mac, Windows, and Linux. And it supports many languages. Inbox, like, JavaScript and TypeScript and Node.js, but also supports other languages via extensions, including C++, C#, Python, PHP, all those languages. And of course, today we're going to focus on C++. It is fully extensible, customizable, and it has built-in Git integration. So with that, let's talk about what's new. So last year here at CppCon, I had the opportunity to show off VS Code for C++ for the first time. So I demonstrated how you, from scratch, start writing code for, build a calculator app from scratch. And with all the IntelliSense help, how to config VS Code to get it building, to get debugging to work all the way. So I'm not going to repeat the same content because I only have 30 minutes today. And of course, don't move, because that's going to just show off too much information there. So if you were not here last year, I strongly recommend check out the recording from last year, where you will see the full IntelliSense building and debugging, the whole workflow. But today, I'm going to strictly limit myself to only talk about new stuff we have built since last year. And what could possibly be new, since we already provide IntelliSense and debugging and code browsing, code formatting, all those features already a year ago. And I guess somebody has seen that on my slide previously. But one word we have heard completely from our survey and if customer feedback was IntelliSense. So what does that mean? If we summarize using two phrases, it was more IntelliSense features and easier to set up IntelliSense. So those have been the two focus areas for the team in the past year. If we expand a little bit more on what those mean, we have a list of all these brand new features we have built in the past year. So today I'm going to demonstrate some of these features within the 30 minutes and see how far we go. With that, let's just switch over to my demo machine, which is a MacBook over here. And if it wakes up. All right, there we go. So here's Visual Studio Code. And first, what I'm going to do is to open a project right here. Now, what I opened is a project called Box2D, which is an open source project on GitHub. This is a 2D physics engine for games. So I basically download the code with no modification and straight just open it in VS Code. Now this is a pretty good sized project, not huge, but it has a number of folders and then CPP files, header files. It's pretty well organized. So if we open one of these files here. So one thing you'll notice right away is you get out-of-box IntelliSense experience with no configuration. So if you hover over these types, you get quick info. like you would expect, you start to get stuff like reference highlighting. If you click on one symbol, it will highlight all the other occurrences in the file. So this is working out of the box, not because I have pre-configured for this demo. It is because we do provide a by default experience for C++ projects. And I'll show you the magic in a second. Now I want to show you a few more features that we have added in the past year. So first of all, something small, might seem small, is now we have completed all the autocomplete features. One thing that was missing before was autocomplete for global variables and local variables and stuff like that. So we have added full support for that. So now if you type in RA, we'll recognize that, and then you get when you type there, you get the full list. And this is no longer based on the tag parser, but this is based on the compiler that we use for IntelliSense. Small thing here. And the other thing we added was autocomplete for pound include. Another, maybe a small thing, looks like, but if you type in quotes, or if you type in angle bracket, you're going to get the list of headers that are available in your workspace or anywhere that you have specified for IntelliSense to look for. So now I can type in, let's say, stream. Now I can start typing my code right here. Int, let's say I just want to define a main function. Of course, I can type in everything by myself. But one thing we figure might be useful is code snippets that would help you save a lot of typing over here. So if I do tab here, it's going to fill in the rest of the main function, and I can just start typing my code right here. Now if I type in std, as you expect, you start to get IntelliSense. Your member list is showing up here. I do cout, and I can type in something here. Again, I get IntelliSense. I get full description of these functions, and I can do that. IntelliSense is going to kick in, and the red squiggle is going to go away, hopefully. OK, it does. All right, so I just showed you really quick that out-of-box IntelliSense experience for your own headers, as well as how you can type against system, types and functions in the system headers. And both are supported right out of the box with no configuration. Now, let me show you what the magic is behind the scene. So if we go to press Shift Command P, and then go to C Edit Configurations. So normally you don't have to edit this if you're OK with the default experience. But this is behind the scene how everything works, and the configuration we use. And in case you want to tune some of these settings, this is where to go. And if you have been using the C++ extension, you might have noticed one big change we have made is this configuration file is a lot cleaner than it was last year. And it was a lot shorter, a lot less stuff you have to deal with. So first of all, we cleaned it up so that by default, we only show you one configuration. And that's based on your hosting operating system. So I'm on a Mac, so we only create one for Mac. Unlike before, we create all three, Linux, Windows, everything is in there in a huge file. So now it's cleaner. Second thing you'll notice is include path here. And here's what the magic is this ** syntax, which means this include path right here is going to be searched recursively. And that is one big change from last year. So one of the key feedback we have heard constantly in the past was it takes forever to configure include path because it was non-recursive. And you basically have to list out every single path that you want IntelliSense to look in. So now with **, you can throw that in for any of your paths. So anything in there, subfolders, we will look in there. And by default, we put ** for the workspace folder, which is your workspace root folder. That means as long as your headers are defined in either your root folder or any of the subfolders, we'll find them. And that's how you get the by default out-of-box experience. This is also a default setting, and we will talk about that in a little bit. This relates to VC package, and we'll talk about that later. The other thing you'll notice, define, there's nothing in there. There used to be a long list that you have to define. Now what we simplified was you no longer have to specify any system defines. We will get that information from the compiler. And that not only defines, but also includes. So the other change here is you no longer have to list out any system include path in here explicitly. What we are getting this from is based on this setting, which is compiler path. That's a new setting that we added. By default, we will check for the existence of compilers on your machine. So we have a set of logic to decide which one has a higher priority. Like for instance, here we found clan being present, and that's the one we're using. We're getting all the system defines and includes for you from the compiler. And you don't have to change it, but if you want, this is where you can change it. So for example, you can change that to GCC, and it will get system includes and defines from there. And then also, the other thing you might notice, for those of you who have been using old versions of the extension, is browse path. So every once in a while, we get asked, why are there two path settings? One is for include, one is for browse. And we have to explain what the differences are and how they work differently and how you're using them. So now we have simplified that situation by simply making browse path optional. What that means is if you don't have that defined, we will take include path and translate that into the browse path. But if you do want that browse path to be different, then you can still do that by explicitly listing it here. And then we, of course, exposed more settings for you. So in terms of language standard, you can now specify what language standard you want to use for C and C++ right in here. All right, so explain to you some of the magic behind the scene. And then I want to show you two more features before we go back to our slides. So one more feature we implemented just recently was colorization for inactive regions. So for example, if I have something defined, if-defs defined in my code, I happen to know there's an apple defined there, and let me find one instance here, which is in this file. Is that, oh, you can kind of see, because we're on that Apple machine right here. So we say, hey, if this is true, then we include OpenGL, this file here. Otherwise, we include glue, which means now this is not active, and then we kind of grade that out so you can visually get the idea of what code is active, which is not. And the same idea here. We'll scroll down the list. And OK, so that's one feature. And then one more thing I'm going to show you, which I think is pretty cool. So this feature itself is not brand new. So the feature I want to show you is if you press Command-T, VS Code has this built-in feature that lets you search for any symbols in your workspace. This is not brand new, but what was new was now we have made the scope of the search to be just your code. So that means when you type in search, we will filter out any system headers. This gives you a much cleaner list and performs much faster, especially in large code base. So for example, if I type in allocator here, you can see everything here is in my code. So this is pretty nice. But in case you do want to go back to the old behavior, and you do want to search for something that's in the system headers, you can still do that by going to the setting file. And then in here, go to workspace setting. Oh, by the way, this is a brand new UI in VS Code. You might have noticed. So it used to be a JSON file based setting file, and now it has nice UIs for different types. You can see drop downs, you can see text box, and all that. Anyway, so let's do just my code, which is under C++. So by default, the setting sets to just my code. But if I switch over to all and then save that and come back to my code and do that again, you would expect a much longer list and includes allocators like from memory file. Okay. All right, let me just go back to this. All right, let's go back to our slides to summarize what we just talked about. Okay, so we saw a couple of IntelliSense features. Semantic auto-completion, so that's mostly for locals and globals. Autocomplete for pound include, code snippets, colorization for inactive regions, and just my code symbol search. So that's on the more IntelliSense side of things. Now let's switch over to IntelliSense configuration. So we kind of touched on two of the IntelliSense configuration features. One was we talked about how include path can be recursive now. So that's an option. The other thing is we now automatically detect your compiler, and then we get system defines and includes automatically for you with no configuration from you. Okay, so that's all nice. So hopefully, if your project only refers to headers that are included in your workspace, everything should just work out of the box with no configuration. But things are usually not that simple. So there will be cases where you might want to share IntelliSense settings across different projects. So that's one thing we have also heard a lot of feedback around, which is I have similar projects. I have external path or libraries I'm using. I want to share that setting across multiple projects. And we now have enabled IntelliSense settings as either a global setting or a workspace level setting. Let me actually go back to the demo machine real quick to show you what I meant. OK, so now we're back here. This is, again, in the settings file. So now you can see we have different levels of settings. So VS Code provides this user level setting, which you can think of that as a global. So anything under this user's account that can be shared across. And this workspace level setting basically applies to every single folder in your workspace. Oh, by the way, did I mention VS Code now supports multiple folders to be opened at the same time in the same VS Code instance? That's what we call multi-root folder support. That's also new. So you can basically come here and then say, I want to add a folder to my workspace. Now you can open a second folder, and you don't have to open multiple instances of VS Code. OK, now let's go back here. All right, so in here, if I remove that, go to extensions and C++. You will find pretty much everything we expose in this file for IntelliSense. Pretty much everything you can find in this UI, which means, let me go here. So let's say browse path right here. And compile commands, compiler path we just talked about. And language standard we talk about, defines, include path. Everything we expose through the VS Code setting file. So you can set once and have that applied to all of your folders or workspaces. And of course, you can always specify something that's unique to the folder. So you can have files, you can have paths defined in here that would be appended to what you have defined for your workspace, for example. So you have these 3 levels of settings you can define for IntelliSense. All right, let's go back and talk about more stuff here. For IntelliSense configuration, Of course, we talk about how you can set up IntelliSense across different projects. And one common ask we always get is, my project is set up to build with CMake, and it's already set up pretty nice, and it knows everything about my include path and all that. Can I reuse that information for IntelliSense? Because I don't want to go through and go back and configure everything myself again. And also, along those lines was support for compile commands.json. So even if your project is not configured with CMake, but maybe using something else or using a compiler to generate this compile command file, you can also use that to configure IntelliSense. So let me demonstrate those two features. Let me close this folder, save, open a different project. So this is the Bullet 3 project, which is again an open source project on GitHub. Another game engine, physics engine. And this one is a lot more complicated. And it has a lot more source code, and it's configured with CMake. OK, let's take a look at how we can use the CMake integration here to configure IntelliSense. And of course, you'll notice that by default, it's already working. Let's see. IntelliSense, because of that magic, the recursive magic I was talking about. Because this project, even though it's configured with CMake and complicated, it is still self-contained, which means everything is within the workspace folder. But let's break that. Let's have some fun there. All right. As soon as I remove this, everything will be broken. All right. Green squiggles. Who has seen green squiggles? Everybody, huh? That means our IntelliSense is not fully working. It doesn't mean it's completely broken. We still do have a fallback experience that's powered by a tag parser. It's what we call fuzzy IntelliSense. It's not super accurate because it doesn't have the knowledge, the semantic knowledge of your code. But it's able to provide you some basic IntelliSense. So even if you see that, it's not that bad. You still get quick info, and sometimes it works pretty well. But there will be times when things get pretty scary. For instance, what you call getX, we don't really know where it comes from. We don't know what exactly, what class it comes from. So this is where you are motivated to configure IntelliSense right, so you can get the exact accurate type. All right, let's try the CMake integration. So one thing to note that when I say CMake integration, it's not something we provide out of the box as part of the C++ extension, but instead we have decided to expose an API for any external extensions to provide us IntelliSense information. So that way it's more extensible. It's potentially able to support build systems beyond CMake. So any external extensions can register with us and send IntelliSense information over. So one of the things we did is we worked with the author of the CMake tools extension, Vector Boo. Thanks very much for the partnering with us. And so this is a really good extension. If you're using CMake, it helps you to configure IntelliSense. It helps you to build CMake projects right within VS Code. So we partnered with him, and then we got the IntelliSense integration to work with our C++ extension. So by default, if you have both installed, when you open a folder that has CMake file, you will get prompt and with a pop-up message. And all you have to say is, yes, I want to use CMake tools to configure IntelliSense. But for demo purposes, since I have already dismissed that message, I'm going to show you a different way of getting that configured. So again, going back to the command palette. And then this time we're going to go with change configuration provider. So this is going to list every single external extensions that register with us to say, hey, I can provide IntelliSense. And in here, I only have CMake. So let's select CMake. So IntelliSense is going to kick in And then green squiggles go away. And we can verify that by going to the get method. Yay! Now this time we are getting the exact type. So let me show you real quick what the magic is. Really not much. Basically, when you do config the CMake tools to be your provider, and this is the one line of code we added to your configuration file. You can change that anytime. Let's say if you want to change a different configuration provider, or if you want to opt out that experience, you can go and do none, and that goes away. And of course, if we come back to our file, the lovely green squiggles came back. The reason I remove that is because I want to show you real quick a different way to configure IntelliSense is to use compile commands file. So this project comes with a compile commands file that's already in there under their build folder. So essentially, this is an array of commands, and each command defined for a single source file, how it should be compiled. And that includes information like -d is the define, and -i is the include. So that's enough for our IntelliSense engine to config IntelliSense for you using just this file. So what I'm going to do is, here real quick, all you have to do is to go select compile commands, and then find the path to your compile commands file and save. And come back. IntelliSense is going to kick in as long as the file goes away. That's done. And we're getting the same IntelliSense again. So by the way, if you do have that file, compile commands file in your workspace root, we are actually going to auto-detect its existence and prompt you a message and say, hey, we find this file. Do you want to use that to config IntelliSense? So everything will be auto-detected, and the magic will be done behind the scene. All right, so that's compile commands and CMake. Last thing, but not least, VC package integration. How many of you have heard of VC package or used VC package? Okay, not too many, like 12-ish people. So VC package, let me switch back actually. VC package is a C++ package manager that runs cross-platform. So it is here. It runs on Windows, Linux, and Mac. It helps you manage and acquire C++ libraries really, really easily. And it's open sourced, so the source code is here on GitHub. All you have to do to use that, take advantage of that, is clone the repo and bootstrap. And it will then you'll be able to install anything as easy as VC package install SDL2. And that's all you need. It's going to pull down the source file. It's going to compile for you. So you get the lib file. You also get the includes, so that's something we use for to power your IntelliSense. So if your project is using any third-party libraries, this will be a really easy way to get those libraries onto your box. And then on top of that, the bonus you get is if you're using VS Code, the support is already integrated into VS Code. So as soon as you have libraries installed via VC package on your machine, our IntelliSense engine will be able to find those includes and just use those headers to power up your IntelliSense. So let me do that real quick. How I'm doing on time? Oh, not too bad. I should be able to finish this one. All right. Let me do something. A different file. So a different project. So in this project, really, really simple. All it's trying to do is to render a triangle on my screen, a spinning, colorful triangle. But for that, it uses the SDL2 library, which apparently I don't have on my machine. That's why I'm getting these green squiggles. So at this point, you still have to go and do all the stuff I showed you, which is to install VC package and bootstrap, install this SDL2 library. And the last thing you need to do is to run VC package integrate install. Essentially, that makes VC package visible to VS Code. And that does all the magic. So I've done all that. The reason I'm still seeing squiggle is because I tricked the system by renaming the file. But as soon as I put that back, so now SDL2, let me reload the window. So everything is kicked off. And the file goes away. All right, now green squiggle went away. Because now we're using the includes from the SDL2 library to configure IntelliSense. Last thing I want to show you is the power of VC package. Not only it can help you manage your IntelliSense, but also you can use the library you just acquired to build your project. So let's do that real quick. Let me get into my build folder and just build my project. And now I can run it. Yay! That's our spinning triangle. That's using the SDL2 library that I just acquired. All right, let's go back.
Sorry.
We're done? 2 minutes?
No, 2 minutes at least.
Oh, I'm sorry.